Okay, project one, week 4. We've discussed last week about the reasons for surveying. We've gone over and reviewed that, the purpose of surveying. And now I have my surveyor with my analyzing rod in place at the correct table position, which is my path of insertion that I've dictated by maximizing or equalizing the undercuts for the G-clasps and minimizing the contacts on the guide surfaces of the distal of 3-4 and 4-4. So each of you will receive some blockout wax. Mine's a little bit larger, yours may be smaller. But we have to keep in mind that the lingual bar is 0.3 to 0.5 millimeters away from the tissue. Now, I don't have to block out the lingual bar at all, because by the time I sandblast, trim, and electroplate and polish, I've probably taken 0.3 millimeters off. So we're going to apply that bar straight onto the tissue, and then from the processes, probably lose 0.3 to 0.5 from those processes. So the first thing I'm going to do is I'm going to add some blockout wax. And you've done this in your acrylic partial dentures with base plate wax. And I just want to make sure that around the gingival margin of the abutment tooth, I have it blocked out. So I've put some wax there. It's still kind of soft. And then I'm going to gently run the surveyor and block out any undercuts that I may have created or that are existing on the distal of 3-4. Remove any of the excess, and then I'll move on to the proximal surface of the 4-4 with some wax. Blockout wax is really rigid to withstand temperatures of hot or warm hydrocolloid, so it doesn't get distorted. We're going to be doing silicone duplication for the first model. And then the second one, which I'll do right after this, we'll move on to a hydrocolloid duplication. So basically what I'm doing here is I'm replicating the master model with all the blockouts. I'll just freehand the excess at the bottom here. Even though there's no undercut on the distal side, I want to make sure that I don't start jamming chromium cobalt into the CEJ of these abutment teeth left and right. I'll demonstrate on this one since I'm on this side. We need to kind of ledge the clasps, meaning I'm going to replicate a ledge just below the red line. So when I'm basically transferring the position that I've marked of my retentive arm, it'll be exposed with a ledge indicating where I'm going to wax the clasp. You don't need the surveyor for this unless I'll do a demonstration of both. So the first one is I'll block out everything, and theoretically, if my surveying is correct, then everything below the survey line should be blocked out. So you can see I've added wax everywhere. I'll take the analyzing rod, which is a straight. There's no taper on this one. And then I've removed everything below the survey line with wax. Now that's one way to do it, and then ledge it. But we've already gone through this process. I think probably a quicker way is you draw on the red line and just below the red line. And remember, don't go to the proximal surface. This is going to be metal here. The ledge would start at not even the, maybe just mesial to the distal facial third of the bicuspid. I don't want any ledges in the guide surfaces. And then I'm going to create a ledge, if you can visualize a windowsill, a ledge that'll be replicated in my refractory model, exactly where I should wax my clasp. Now, with a lot of experience, you may forego this, but we're preparing ourselves for a college exam, and then by asking you to ledge the clasp, you have a fundamental academic idea of where it should be placed. Now, just so there's no undercut, I'll block that wax all the way down to the sulcus here to ease the model of removal from the silicone. There's no rush here. So whatever your famous or favorite waxing tool is that you would use in Crown and Bridge, I would use here to build up the Blockout ledge for my G-clasp on 4/4. Now, the ledge will be actually a little bit below the red line because there is a profile thickness to the clasp. There's a profile thickness, meaning there is a incisal gingival width to the clasp. So I'm going to ledge here. I'm just going to remove some of the wax that I've gone too high. And you can see I've exposed my red line. Maybe we can zoom up a little bit here. Oh, sorry. And you can see I've exposed my red line and created a nice sharp ledge. I don't quite have it on a 90, but maybe like a 70 or a 65 degree angle here, tapered it down. But 90 is fine. I'd go a little bit less than 90 just so it's smoother. And then allows me some freedom. So there you have the buckle arm of the 4/4 ledged. And what I mean by that profile, I'll just show you an example of a clasp profile that you have in your wax kits that we're going to use. So just to show you, this is a wax profile of the thickness of a clasp, and it needs to go right on top of that ledge. So you can see there's a incisal gingival width to the clasp, or a height if you want to call it that from this angle. So I can't put the ledge right at the red line because that would be above it. So kind of semantically a little bit, that this will cover exactly. Now I'm just putting it on the master model. It will not be waxed up on the master model, but this is what it's going to look like, maybe with the mesial half or just less than half below the height of contour. So let's move on and do the other side in the same fashion. So I've done the guide surfaces of the abutment teeth. And this is the very first one we're doing. So it's very simple, meaning only 2 clasping teeth of 2 abutments, 2 guide planes. Path of insertion is somewhat simple. And I chose the class 1. So if we go really awry on the shoulder height of our retentive arms, potentially we may be able to fix it by cutting it off and adding a Rottweiler clasp, which would still be fundamentally correct for the class 1 design. So I've kind of like erred on many ways or many avenues to build in success for you on the first time here. Now we're doing this blindly, where maybe we're not aware of the steps to follow. We've got refractory model. This is the survey design blockout refractory. Our prescription is done already. And then once we duplicate the model with silicone, we're going to have to start on our next one, because there's a lot of downtime for the refractory material to set, to bake, to spray, to wax. So just in case we've lost our step, we survey design block out prescription, duplicate to a refractory model. That refractory model will be heated for about 15 minutes at 250 degrees, then sprayed with a model hardener. Then after the model hardener is set and the model is cooled off, we'll begin our wax up. The wax up is then sprued and then invested. That investment's about 45 minutes, the same as it is to take an investment model. Setting time, so about 45 minutes, then is taken to the oven to put in, we can do a fast temperature rise, at least heat soak for 15 minutes at 1850 degrees or 1861 degrees. Then we're going to cast, wait another hour for it to cool down, sandblast, trim off the sprues. Rough trim the parcel, meaning take the flash off if there's any or any bubbles. Hopefully there's not. And then go to the deplater, which is a pre-polisher or electroplater, but it's a deplater in reverse. So we're actually stripping off layers of chrome. It's a pre-polisher. Then we're gonna attempt to fit the parcel, and then after fitting, wheel rubber wheel. We'll use rubber points. We'll use a low shine. And we'll use a high shine. Then the framework's done. We'll remount the master model. Set up 6 teeth with the occlusion that we have with the opposing. Dismount the model. Invest the model in the brass flask. Split pack. Heat cure. Divest. Hopefully our model will survive if we've invested correctly. Check the bite for any occlusal discrepancies. Trim, rough trim, fine trim, pumice, low shine and then high shine. And then project 1 is complete. And then we'll hit the repeat button for projects 2, 3, 4, 5, 6, and hopefully 7. And then as well, hopefully on number 6 or 7, we'll introduce the CAD-CAM version of this. So we're doing this digitally. You can see it's not a lot of work, but the computer will do this digitally on any certain angle that you tilt your model digitally. On the screen, I can show you that. People just look and go, oh yeah, it's so much easier. It is for the Blockout, most definitely. Faster too. Although the digital wax up similar to an analog wax up. And the casting process is the same. I mean, just as someone can get pretty fancy with the CAD-CAM software in designing a partial denture, there's equally someone just as fast to do the analog wax up. So I think 15 minutes for each. Except the digital one has to be printed, not just digitally done. It has to be printed in a PMMA resin, and there is some processes where it has a laser sintering buildup of the chromium cobalt, and then that takes time, but overnight. So I'm making a nice sharp ledge here for my G-clasp on my bicuspid. So we've recapped now. I went through the processes briefly there, and those processes you'll commit to memory after repeating them over and over. Blocked out the guide planes. If there is no undercut, at least block out the gingival margin of the tooth. As you can see, there's no wax distal to the guide surface here. I don't want that ledge over here. You'll create a ledge in your guide plane. This tooth has a little bit of wax in the middle, and then the survey line and the gingival margin. So if I zoom up close, we've made this tooth basically flat here. Now, in order to block out, you need to know the design. We did the prescription last week. We're going to talk this week about the acrylic retention grids. And it comes in different thicknesses, meaning there's a different thickness of the acrylic between the tissue and the mesh lattice retention. It comes in different types. Here's some clear ones. Here's the one we're going to use. It's about 0.6 millimeters thickness. So it can come in 0.4, 0.6, 0.5, 0.8. And let me zoom back out so we can kind of see what I'm doing here. Because this is important. Everything's important. So you'll have this stuff in your wax kits here. I'm not sure how big of a sheet. But it is almost a transparent pink. It's very soft, so don't put your fingernails through it or anything like that. I would probably peel off a strip about half inch, 10, 11, 12 millimeters. And we're going to bring our model here. We don't need the surveyor anymore. I know it's such a detailed instrument for such really not so long of work. But I can see here, let's zoom up now, where I have my finishing line. This is the external finishing line that I drew here. This is the junction line between the exposed lingual bar and where my acrylic is going to finish of my freehand saddle. So what I'd like to do, at least for beginners, if I've drawn that line as I have the blue one here, straight down the guide surfaces with a slight distal cant to it, I'm going to line my block up wax exactly to that blue line. If I've gone over the blue line, this is where your surgical knife or Bard Parker knife comes in handy. Please surgerize all the way. And maybe I should go beginners. Let's go all the way from the lingual sulcus to give us freedom in our wax ups. Meaning a lot lower here. Where the drawing is underneath the model, distal to the prosthetic 6, I'm going to surgerize this wax here. Take it off. Now, at this stage, it really adheres to the model, assuming our model is dry. But just to make sure, I want you to, now this is really, really, really careful, listen up here now. I want to seal the sulcus border of the wax to the model, as such. And I want to seal the buckle of the blockout wax to about here. So now it is sealed. I don't want any hydrocolloid or silicone getting underneath there at all. Now, this cast partial won't have a horizontal shoe extension, so I want the finishing line, or external and internal finishing line, will be slightly offset, but it'll go straight up to the guide plane. I've really taken a little nodule of wax off there so it's a flush finish with my block out. And there we have one side. Again, seal the lingual sulcus side and seal the buccal side. Do not seal this sharp ledge, 0.6 millimeter created ledge, and do not seal the distal extension or the distal line of the blockout wax. And then I will go and I'll do the same on the other side. I'll go all the way down pretty much to the sulcus, over the ridge. Sorry if I'm off the screen there. Let's zoom out a bit here. I'll take my surgical knife and I'll cut exactly where I drew that I anticipate the distal of 6 being. Now this is the framework. We're going to have acrylic finishing all the way up, covering the retromolar pads. Except when we look here on the angle, we know that there's less room distal to the roughly distal of the 6. So I want to maximize my space there for a 7, so I can have the gingival margins of those prosthetic teeth exposed as possible. I'm not compromising the length of my prosthetic teeth at all. And I also have less room in the bite here. If we generalize and say people that are posterior edentulous class 1 and they've got natural dentition, chances are they've over-erupted into the back section, even further minimizing my space. So there's many reasons just to stop there at the deepest part of the edentulous area. Once again, seal the lingual sulcus and only the lingual and only the buccal of the blockout wax. Now I'm blocking out way lingual and way buccal sulcus of my blockout because I'm giving myself freedom in the wax up. I'm not going to pigeonhole my wax up that I have to be exact. And then I'm going to resharpen this with a little knife, just trim a little bit there. I've got some debris. And then now I have my sharp internal finishing line. Now, this will come clear when we get to the casting stage, external and internal finishing line. For now, being project number 1, I just need you to follow along. Don't challenge what I'm doing by saying, well, that took so long, I'll do it faster. Stick with this. I've already told you many times that I'm the epitome of the let's say, lazy tech. So if there's a shorter way, I've already gone there. If there's a better way, I've gone there too. And this is a mirror of both. Okay? I'm just going to further seal the outside here. Now, this is going to be a silicone duplicate. So what I'm going to do is I'm going to take my denture wax, which I have plenty of from my setup on Friday, and I'm going to block out the whole anterior section. This has nothing to do with the casting. This is to facilitate the ease of removal from the silicone mold, which I'm going to create very shortly for you. And then we'll watch another video on the refractory, and then we will watch another one on the wax up. And then I'm going to anticipate everyone to do the same. We'll stop, make sure everyone's at the same step. So this first one, nobody falls asleep because we all got to be at the same speed. Don't slow us down. Don't rush, but don't waste our time either by leaving the room or disappearing on us. I know that's not you guys from experience already this year and last year, but now I'm not disturbing my ledge. Basically, I could use a surveyor, but you can see it's not necessary. I'm just going to basically block out the whole anterior section, and it doesn't matter how much or even how little, but some, so I don't rip the silicone or it's not really difficult to take off. So let's recap here. I should, if you look at many blockout manuals, that they will block out the lingual bar with some wax, meaning they'll take the blockout wax and go down here with it. Now, in the previous time, I've had students do that, but students love wax. And then I noticed that they would always put too much, and then we have to take it off. So my understanding here is now that we won't put any. Once we do sandblasting, rough trimming, deplating, polishing, we've lost 0.3 of our internal surface of the lingual bar, which is exposed to the tissue. So therefore, I won't block out the lingual bar unless I have undercuts on my tissue side. So I've got my buckle arms ledged below the height of contour. And maybe what we'll do, just to make it more work, we'll block out, and I guess I should have done this before the free end. But we'll create a little ledge for my reciprocal arm of my G-clasp. Now, this is the first one, so many people that may be watching this with a lot of partial denture experience, they say, hey, there's a class 1 and with rotations. Where's the indirect retention? Where's the indirect retention on this cast partial denture? We'll save that for another casting. Just to go through the process, we're trying to achieve some success. Maybe we'll do minor connectors and cingulum rests on the canines at a later date, if we were to do it again, like something commercially. But here at the for the students, let's just get a casting that we can. First one. So I've created a ledge below my blue line because there's a profile of that wax. I've created a ledge here. And there you have it. I ledged the reciprocal arms. I've ledged the buckle arms. I've spaced with 0.6 millimeter blockout wax for the mesh retention exactly to the distal of the first molar. And I've just freehand blocked out the anterior teeth that really aren't involved in the framework design at all, but this is going to facilitate us taking it out of the silicone a little easier. If there's an undercut at the back, like outside the pattern I'm talking about, maybe I want to block out here the little undercut of the internal oblique ridge here. This will facilitate it coming out easier. Maybe there's an undercut here, I'm not sure, but it doesn't hurt. I'll be on the safe side. And again, that has nothing to do with the design because we know where the design is going to be. So my next step is I'm going to duplicate this with a silicone or hydrocolloid. First case, we'll use silicone. And we're going to use silicone, so then if your wax up or casting doesn't turn out for whatever reason, we can quickly make another refractory model. And you can make another and another and another, and you can keep casting till the cows come home, I guess, for the first one, and I want you to be successful. So you may have one of these. These are actually investment rings. There's a blue one, and you'll put this in here. You'll seal the mortar to the base so it doesn't move around a bit in here. You know, I would keep distance of the edges equal all the way around. It comes in different sizes. We may have a red one, I'm not sure. It's a little tight for this case. So you need to Vaseline the ring to duplicate the model. I'll use a metal duplicating flask, which is like a lot of silicone. So we're trying to preserve some silicone because it's roughly around $10 to $15 a model duplicated. So that's why we want to have those blockouts checked before you go any further. Your silicone will come in two parts, base and catalyst. And the base and catalyst, depending on what cups you'll use, we'll explain to you, the teachers in the classroom will explain to you how much, or we'll pour it out for you just to preserve it. And then what you're going to do, I think you can handle this, is I would pour the base in first. Then there's no rush to mix because the base will not set if I'm pouring. I guess it doesn't really matter, but I have a tendency to put the base in first because you're going to mix it quickly. It can be messy, so be careful, okay? Let's not get it all over the counters. And then I've got the exact equal mix, 50-50 of my catalyst. And I'm scringing right down to the last drop. And there's not that immediate rush, but you do have to work swiftly. And now this is a blue colored one. It's the same brand as Zermac, except this has a higher shore hardness. I think it's 32 and the other one's 22. So what does it say the shore hardness is here? 5 minutes working time, shore 32, shore A. It's pretty firm. It's a lot firmer than the orange one you're. So I got 5 minutes. This is a vinyl polysiloxane duplicating material. I mean, this is the same as an impression material that comes out of a mixing tip intraorally. Oh, I'm sorry, I banged that. So I'm going to use the metal duplicating flask. It doesn't really matter. You'll probably use the blue one, but the same principle applies. Now you have the hole to pour into. I'll just have a smaller hole here to pour into. And I think if I pour from a height above, it's a little bit better. Let's say like 5-6 inches. Well, the gravitational flow of the silicone with the gravity. And there's no vibrating here, okay? This stuff is very fluid. No vibrating. Now something we can do, which I will a little off screen here, that if I do all my procedures under bar pressure, meaning in a pressure pot, okay, pressure pot with no water, or an air pressure chamber, I'm going to make my silicone under pressure. So once I've poured it all in here, I'll put this in the pressure pot. So maybe we do this in the classroom near the pressure pot. And it doesn't matter if somebody opens it. It's not that critical. But it would be nice if you could keep it in there for at least, 15 minutes. The initial setting time, it says, is 10 to 15 minutes. I'd like us to wait a whole 30 minutes before separating this. And I'm just scrimping again for the last bit of silicone. Try not to make a mess. And I'm going to take this now, and I will put it in the pressure pot. When we return, we'll be proceeding with the refractory model and the wax up. Okay.